Hey guys, welcome back on part 2 of reviewing how to complete the square. So, this is still on page 10 of your packet, and we're just working on the last two questions, questions 3 and 4. So for example 3, we first have to isolate the x values because this 26 needs to move to the other side of the equation. So what we're going to do is we're going to subtract that 26 to move it, so that we have only x terms on the left and any non-x terms on the right. Keep in mind you want to leave a space so that you can add something in there in the next step. And then when you combine 8 with negative 26, you're going to end up with negative 18. Okay, step 1 is not done yet. We still have to find the three b's. So that would be regular b, b over 2, and b over 2 squared. So to start with b, it's always going to be that middle term that is attached to the x, so that is negative 10. To find b over 2, you're going to take negative 10 divided by 2 to get negative 5. And to find b over 2 squared, you're going to take that negative 5 and square it to end up with a positive 25. Now, of those three terms, you are going to use this 25, the b over 2 squared term, to add to both sides of the equation. So we have plus 25, plus 25, and then we are on to step 3, where we're going to factor the left side of the equation as x plus b over 2. Now because our b over 2 is negative, you're going to use this negative 5 in the parentheses, and it's going to be squared. And when you combine the like terms over on the right, negative 18 with positive 25 gives you a positive 7. And we're on to step 4. So step 4 says to take the square root of both sides of the equation, and the square root and the square are inverse operations, so they are going to cancel each other out. So you're just going to end up with x minus 5 equals, don't forget the plus or minus. Now 7 is not a perfect square, so we would end up with a crazy decimal that never ends or repeats. So we're just going to keep it as radical 7. And then we just have one more step. To get x alone here, we are going to add 5 to both sides. And your final answer can be written as simply as just writing x equals positive 5 plus or minus the square root of 7. And that's in simplest radical form. We're just going to keep it like that. We could round and find the decimal that those values turn into, but I like this form better, and that's the way it is. Now, if you're not sure if it's a perfect square, you might want to write down some perfect squares that you should have memorized. So we can do that real quick. So starting with 1 is a perfect square, and then 4, 9, and if you're not sure how I'm getting these numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9. So on to 4 squared, 16, 5 squared, 25, then 36, 49, 64, 81, 100, 121. I can't fit much more, so ... But you get the picture. So anything that you can take the square root of and you'll get a nice whole number would be considered a perfect square. Okay, on to our last example, which is example 4. So with example 4, we have to first isolate the x terms. So in order to do that, I need to add 55 to both sides of the equation. And always remember to leave that space so that you can add something in the next step. And in that first step, you also need to figure out your three b's. So b over 2, and b over 2 squared. So starting with b, so b is that number in front of x, that's going to be a -6. b over 2 would turn into -3 because -6 divided by 2 is -3. And then b over 2 squared is going to turn into 9 because -3 squared is a positive 9. Now in the next step, you're going to take that b over 2 squared term and add it to both sides of the equation. So +9 and +9. And then you're going to use the b over 2 term to factor because x minus 3 squared is how you could factor the x squared minus 6x plus 9 because -3 times -3 is a positive 9 and -3 plus -3 is a -6. Now when you simplify what's on the right hand side, you're going to end up with a positive 64. So in the next step, which is step 4, you're going to take the square root of both sides and you're going to end up with x minus 3 equals, remember the plus or minus, and the square root of 64, since that's a perfect square, turns into a nice 8. And we're on to the last step. So in the last step, we just need to solve for x. So we are going to add 3 to both sides of the equation to get x alone. And your two options are 3 plus 8, or x could equal 3 minus 8. So if we simplify that, we are going to end up with x equals 3 plus 8 is going to give us 11. Or if we do the 3 minus 8, we're going to end up with a -5. And those are the roots, and that is going to conclude our notes for today.